Hello everyone, I'm Krishna Kadali and I'm here to present a presentation on Gage R&D study and proscality at Metromol Design, and we did this along with Lama and Shipra under the supervision of Mr. Alan Chan, who is a quality engineer at Metromol Design. Introduction. Metromol and Design was founded in 1973 and has headquarters in Rogers, which is in Minnesota, and it has been satisfying its customers up to mark with their manufacturing services. Besides that, MMD is an ISO 9001 and ISO 134857. And coming to the problem statement, as we have variation in measurement, we need to know the basic reason that gives this variation. And there are two types, common cause variation and special cause variation, so we can eliminate the special cause variation. And then we need to examine the process capability to make sure that our process is going within the specification limits. And the main objective of the project is, to perform a gauge R&D study to check variation in the measuring process, and as gauge capability is required to have a confidence in the SPC process. The scope of the project deals with performing gauge R&D study on monolith plates and check thickness gauge, make a SPC chart using the X-bar and R-bar charts, conduct a process capability analysis, etc. Then when coming to the methodology, a quality characteristic such as thickness, length or width is chosen, and then a gauge instrument is used to measure it, and then we use 10 plates for measuring it. Each one was measured by 3 students 3 times, and then for SPC charts, one student measured 4 sets of parts. Each set is considered. The inherent repeatability and the RM chart was conducted through the measuring one plate by student 25 times, and then these were put in the mini tab, and then the results were applied. When coming to the ANOVA gauge R&R, we can find that the degrees of freedom are 9 and the total is 89. So degrees of freedom can be obtained by 10 minus 1 is equal to 9, and the total is 90 minus 1 is 89. And then coming to P, we have 0.00, and then for operator ID it is 0.23, and for part number into operator ID it is 0.01. So when coming to this, we can analyze ANOVA. So for part number H0, the means are equal. So we can, as it is 0.00, we can tell that the means are equal, and this is good. And when coming to the operator has no effect because it has p-value is not less than 0.05. That means 0.236 is greater than 0.05, so operator has null effect. And then coming to part number, we have that 0.01, so it far less than 0.05, and we can reject null hypothesis. When coming to ANOVA gauge R&R, and then we have percentage contribution of 4.56 in total gauge R&R, so it is far less than, it's really good. And then coming to this percentage tolerance, it's 2.48, and we can clearly tell that it's far less than 10. And then to part variation is 97.69 in percentage steady var, and which is a good indicator telling that it's far high. And then in the before slide 2, we have that part to part in contribution is greater than 92, and which is a good indicator. And the percentage tolerance is 11.35, it is also good. And here number of distinct categories are 6, which is greater than 5, so the gauge are acceptable. Then coming to ANOVA gauge R&R, this gauge R&R ANOVA for thickness, we have the percentage graphs, and then gauge R&R, repeatability, reproducibility, and part to part. And here when coming to the sample range, Krishna has better repeatability than Lama and Shipra. So when we compare, he has good ranging products, and we don't find a lot of differences. And then in the average thickness by operator ID, we can see that Krishna, Lama, and Shipra are almost equal, and it has good repeatability and reproducibility. When coming to the statistical control charts, and we can find that in the X-bar chart, it is out of control. I mean the black one is out of the red lines, and then here sample range, it is in. And then coming to statistical control charts, it is the sample mean is under control, and the sample range is also under control. And when coming to the process capability, we can find that the individual values for all the 32 plates are like wavering, and we have only 1 point at 5, which is out of control, and everything's fine. And when coming to the process capability histogram, this is a process capability histogram, and we can find that it has shifted to the right and crossed the USL, the upper specification limit, by around 0.2 points. And then when coming to CP, it's 2.90, and it is greater than 1.33, and it is acceptable. And the CPK is minus 0.60, whereas the target is 4.2. So And then we have fixed the target as 4.2, which is 80% of the mean, and then we found that the CPM is 0.27, which deviates from CP, because the target and the achieved value are not equal. That is the main reason. Finally, the results. The gauge arrender is acceptable. Process is out of control, but it is capable. The process is capable but out of control. The equipment that MMD uses to measure the thickness of monolith after lamination process is suitable. Everything's good. We need to make a correction action to bring back our lamination process, which is shifted out of the specification limit. And recommendations for MMD are: they must use the same equipment, examine the repeatability test again, but we encourage the MMD to do adjustment on the perform machine design to have the process again capable and under control. Thank you very much.